Okay, cool. Okay, so with workshop 6, and this is going to be our workshop on databases. So we're going to be hooking up our Catbook app with databases, specifically MongoDB database. But what is MongoDB? As Akshash mentioned in his lecture, MongoDB is a NoSQL JSON-like database, which means that MongoDB stores things in JSON-like objects. So when we get objects from the database, or when we put objects into the database, we're basically putting them in the JavaScript object format. So we have fields and we have values. And so when we code in JavaScript, we often work with these things called objects, right? And these things have fields and they have values. And this is a very natural way to think of data. And so this is exactly the format that we're going to be handling our data in MongoDB. And so this makes it a lot more convenient than if we just put it in a SQL database, which is something that's like turning this whole thing into tables, right? This is a lot more logical, which is why, and more convenient, which is why we're using it. Okay. And so again, why we use MongoDB, it's very efficient when we need to write a lot to the database. So it's very quick for us to put things in the database, in other words. And if your data, if you haven't really defined the structure of your data, so like if you haven't really defined what fields you want to store or what properties you want to store, MongoDB is really good for that because it's very flexible. So it allows you to change like the fields that you want to store relatively easily. And it's also very easy to use. So it's very flexible. And so we can think of a MongoDB instance, or in the Atlas case, if you think of a MongoDB cluster on the Atlas as a storage warehouse. And this warehouse has individual storage units. And these storage units can be thought of as a single database. So each project will have its own storage unit or database, right? So in the context of WebLab, each team will only need one database for your projects. So one website will only need and only have one database. And within these storage units, we have boxes that store things that are of the same type. And these boxes are analogous to what we call collections in MongoDB. And collections store objects or documents that have the same structure. And we'll define more clearly what it means for objects or documents to have the same structure later on. And these objects objects stored in the boxes are known as documents. And so, for example, we can have a box full of Shiba plushies. And all of these objects or documents have their own properties, right? So they have things like how angry the Shiba is, or the color of the Shiba, or the length of the Shiba, or how poofy it is. So all of these properties are things we want to kind of store information on the object. And so those are called the fields of our document. So just to reiterate, a document is basically like just a JavaScript object. And the fields are the things we want to store, and each of these fields will have its own values that quantifies the properties that we want to store, right? So the color will have values such as, like, for this case, it would be like coffee. Poofy, it will be very poofy, and how angry, it might be very angry, etc. So just a recap of the overall structure of MongoDB is that we have our MongoDB instance, which is like a cluster on Atlas. And each cluster has a bunch of databases where each database belongs to a single project or a single website. And within each database, we have collections that groups together things of the same structure. And these things are what are known as documents. And these documents are basically JavaScript objects. And like what we've been handling in JavaScript objects, these objects have fields, which are the properties we want to store. And these fields have corresponding values that are the things that quantify these properties. Okay, so another high-level overview of the whole kind of storage facility analogy. So we have our whole storage facility. Within our whole storage facility, we have individual storage units. And within these storage units, we have a bunch of boxes, and all of these boxes store things of the same type, right? So we have a box full of just screws, box full of just hammers, box full of just shirts, etc. And so we also would want our collections to have things of the same type. And again, I'll define it more clearly later on. And so in MongoDB language, we have our instance, overarching instance or cluster, and then we have our individual databases. Within the databases, we organize the data into collections, and within each collection, we have objects that have the same structure. Okay, so does anyone have any questions? If so, feel free to drop them in the questions doc or put them in the chat. Okay. Okay, so we're not actually going to interact with the MongoDB API itself. We're actually going to interact with it through this thing called Mongoose, which is a Node.js library that makes our interaction with MongoDB a lot easier. And we can think of Mongoose as a wrapper that allows us to interact with MongoDB. And what this means is that, for example, if we want to add the data to our stories collection, so say we have a collection of stories, and you want to add a story to our database, then traditionally what we would do is we would call the MongoDB API, make a post request, and do all of that wiring. But what Mongoose does for us is it kind of just hides all of the details of the post request away, and we can just add our object into the database by calling like a simple function like .save, for example. And so it just simplifies the process by a lot, and it makes it a lot easier. And beyond that, Mongoose allows us to connect to clusters, create documents, or basically just create objects within collections, and then interact with the database, like getting data, adding data, editing data, etc. Okay, but more than that, we need Mongoose because if we didn't have Mongoose, our databases would be quite messy. And this is because Mongo doesn't guarantee that all documents in a collection have the same structure. And so what it means for all documents in a collection to have the same structure is that these documents must have the same fields, and these fields must have the same data type. So for example, our comments object and our stories object, they have different fields, right? The comments object, if you guys remember, had this additional kind of parent to it, while our stories did not. And so MongoDB API by itself doesn't enforce the fact that if I have two different structured objects, I cannot add them to the same collection, right? So we can start out with like a box with just nails, but MongoDB will let us add other things to this box with nails. And then over time, it won't catch any of these. So then you can just have a lot of random things that aren't nails in your box. So in the stories and comments analogy or case, if MongoDB will let us add story objects to our comments collection. And that's not really good because when we want to pull our comments data from the comments collection in our MongoDB database, from our MongoDB database, then when our code, front-end code, kind of tries to render the comments and kind of map it to its parent, it won't find this parent field, and your website will kind of break, or it will run into errors, and you'd have to go in and try to see what's going on, maybe go into the database and try to filter out all of the data that all of these stories that are stuck in the comments collection, right? So that's not really optimal, which is why we want to have only comments and all of the comments in one collection and all of the stories in one collection. And we don't want to be able to accidentally add a story into the comments, which is quite easy. And so what Mongoose does is that it throws an error if the structures don't match. And how we solve that is by using schemas. So schemas are basically what define the structure of your documents. And what this means is that it defines the fields that all of your documents have and the data type that your documents have. So we'll see an example of that. So this is like an example of a schema. So it defines what each field is called. So we have a name field, age field, and hobbies. And each of these fields, we define the data type that they must have. So a name must be a string, an age field a value for an age must be a number, and a value for the hobbies field must be an array of strings. So this JavaScript object would basically just match the schema. So if we have a collection that follows the schema, so all collections have to follow the same schema. So all objects of a collection must have the same schema, must have the same fields and the same data types for each of the fields, right? So if I try to add, say, like hobbies as a single string instead of an array of string, and I try to add this object, this barked object, into a collection that follows this schema, Mongoose would say no. It would give me an error, and it would not let me add that barked object into the collection, which is good because if our data, if our front-end code tries to process hobbies, for example, to get the length of, or not the length, but maybe like the 0th entry or some entry of the hobbies array, then it might throw an error because it's just a string, right? And so that's not what we want. So we use schemas to kind of enforce what fields we want to have, the names of the fields, and the data types that each of these fields have. And again, these schemas are a way for us to structure our MongoDB documents or objects. And so we use it to specify the fields that an object should have. And again, each collection should have its own schema. And so objects that don't have that schema will not be in a particular collection. But another thing is that different collections may follow the same schema, but they might store different things, right? So we might have a database for apples and a database for oranges, and both of them follow like the same schema. So say they follow a schema that stores how round the fruit is and how sweet the fruit is, but they're two completely different objects, so we want to keep them separate, right? So we want to, in other words, multiple collections can share the same schema, but they should be kept in separate collections. And how we deal with this is by, so these are schema types that we use to specify the types of the fields. But yeah, so basically how we deal with the fact that multiple collections can have the same schema is by defining models. So models are basically like a wrapper for the collections in MongoDB or Mongoose, and they basically let you construct documents, get documents, and post documents. So it's basically a group of all objects that are in the same collection, right? So a collection isn't just defined by the schema, it's also defined by the objects that go into it. No, in other words. And so that's what a model is. So generally, we can create a Mongoose model by following these two steps. So first, we need to create a Mongoose schema. And so we can define this user schema here by using the new keyword and then using the schema method from Mongoose. And inside this schema method, we put a JavaScript object that represents the fields, that has the fields that we want in all of the objects that follow this schema. And for each of these fields, we put down the data type that we want each of these fields to have. So name must be a string, age must be a number, pets must be an array of strings. And so once we've defined our schema, we can put this user schema into our Mongoose model. And we use this by calling mongoose.model. And so this first argument is the name of the collection we want to make. Right, so this is going to be our users collection. And the second argument is going to be the schema that this collection will follow. So we can totally reuse this user schema and make another collection as well. So if we want to, say, track like all of the users who are blocked, we can create another collection or another Mongoose model by saying const blocked users equals to mongoose.model. And the only difference we would make is to have like a blocked user as the collection name, but we would reuse the same schema. And this would create another collection that would store all of the blocked users, right? So again, like different collections can have or follow the same schema, but they have different purposes, which is why we kind of separate them out. And to create documents or objects that we want to store in our collections, we would first have our Mongoose model, or basically our collection. And so this is going to represent our user collection again. Then we define our object, the object that we want to store in the collection or in the model. And we do that by instantiating an instance of this collection class. So we do that by adding this new keyword, and we say new user. So we want a new instance of the user collection, and inside the definition, we want to instantiate the values that the object will have, right? So this object will start out with a name of Tim, with an age 21, and a list of pets, and one of the pets is Cloudy. And once we kind of define what object we want to store in our collection, that's not the end of the story. This doesn't automatically create it, add it to the database. What we have to do is we have to use the .save method on the object that we want to save. And this will then create the object and add it into our collection, our user collection in our MongoDB database. And so .save returns like a promise. So it returns the student or the object that was added to the collection. So in this case, because we saved Tim, or we added Tim to our collection, then MongoDB will return this object that we added, or Tim, as student. And so we would expect it to log the name Tim, right? Because student will basically be the same as Tim. Okay, so altogether, we've actually coded all of these for you guys already, but just to go through it so you guys can kind of understand what the code is doing. So the first thing we need to do is we need to import the MongoDB Mongoose library into our code. So we're doing, that's what this line is doing. And then we need to use our SRV code, which is how we access our, what we need to access our database. And we need a database name, right? And don't worry about the options. This is kind of a little bit advanced and beyond the scope of this class. So we're not really going to cover it here, but just so yeah, don't worry about this part. And then once we have our SRV, we're going to connect to our MongoDB database by doing mongoose.connect. And we're going to give it our SRV. And then once it connects, hopefully it will say connected. And this is going to log into our terminal that we ran npm start in, right? So the server terminal. And then once we connect to our database, we can create a new schema. And so here we create a new user schema, and we create a new model or a new collection. And mongoose.model by default will create a new collection in our database for us. So it will create the user collection in the test database for us. And then once we create our collection or our model, we can then use that to create or instantiate a new object that we want to store into the collection. So this line is basically instantiating an object that belongs to the user collection that has the following fields instantiated. So name of Tim, age 21, pet called Cloudy. And then after we've made our object that we want to store, we call .save, which sends or saves the object in the MongoDB database, and then we can use the callback to kind of print out what we've saved, basically. And so that's the general kind of rundown of how to use MongoDB. So just to summarize, we need to import Mongoose into our code, and then we need our SRV to be able to connect to the database. And once we connect to the database, we can define our schemas that we need for our collections. And once we've defined our schema, we make a new collection based on that schema, and we name our collection to be something. And once we have our model or our collection, we can make an instance of that model to make an object that belongs to the collection that corresponds to that model. So in this case, this is a object, or Tim is a object that will belong into the user collection and follows the schema exactly. And once we create this object, we can then add it to our database by doing .save. Okay, and if we look on Atlas, all of these would create, first it creates Mongoose has created a test database for us, and it created collections called users. Now this is slightly different from what we've had here when we defined what our collection is called. So here we've defined the collection to be capital U and there's no plural, but Mongoose automatically adds the S and it like uncapitalizes everything because it thinks that it's more kind of logical for a collection to be plural. So it would automatically do this for us. And we also see here that we have the Tim object added to our users collection. And it has all of the fields that we've specified. It has age, name, pets. Don't worry about this version for now, but do notice the field called _ID, right? So what is this ID? So Mongoose or MongoDB automatically adds this ID for us when it adds our object to the collection. And this is basically a unique identifier for every document in MongoDB. And because it's such a long string, it's highly unlikely that two strings or two IDs two objects would have the same ID. So it's highly unlikely. And one way we use it is to identify objects, but we use it more for defining a relationship between documents. So when we want to link collections together. An example of this is when we had our stories and our comments collection, right? So for every comment that we had in Workshop 3, we wanted to add a parent identifier. So essentially, we can just specify the ID of the corresponding story that it belongs to, and that will automatically link the comment with the story. So it would link every comment in the comments collection to a stories in the stories collection. So while there's no actual linking functionality in MongoDB, we can use IDs to link these two collections together and form a relationship between them, because every comment belongs to a certain story, and we identify the story that it belongs to with this ID field. And we can use this ID field to find the story in the stories collection. Okay, and to find documents, we can use the find method on the model. And so this field is basically describing what kind of filters we want to have to filter the collection. So here there's no no requirements, so it would return all of the users in the database. But we can specify like what properties or what fields and what kind of values that we want to get from our database. So we can specify, say, if we want to return all of the users who has name Tim, then we should specify in this object that we want to find all of the objects with name Tim, and this will then return all of the objects that have this field, have this property as Tim. And we can define more properties that we want to filter out. So we can try to find all users with the name of Tim and who are 21 years old. And this will do just that. So you can add any number of parameters in here, and it will just kind of filter out through the database and give you all of the objects that follow the same or have the same values for these fields. So yeah, again, you can add as many parameters as you want. And if we want to delete documents, there are two ways to do that. So one way is to use the delete one method. And typically you would put like the ID of the object in here, but like in this case, it's finding one user with the name of Tim to delete it. But this doesn't guarantee that. So if you have multiple users with the name of Tim, it doesn't guarantee that it will delete the user that you want to delete. It will just find the first user in the collection that has the name of Tim. So, which is why you typically want to use the ID instead here. But yes, you might be careful with that. Another way to delete things is to use the delete many method. And this method basically deletes all of the objects in the collection with the name of Tim. And so you also want to be really careful because you don't really want to wipe out, wipe everything with that follows the same, that has the same values unless it's really intentional. Right, so this will delete all of the users whose name field is Tim. So yeah, again, just to recap, delete one just finds a random object that satisfies the condition and deletes it, and delete many deletes all of the objects that follows this condition. And so just to recall the Mongoose structure, we have our API, and we use it to call methods provided in the model. And these methods then talks to our user collection in the database, and it like returns things or does actions to the database itself. And there's a lot more to learn about with Mongoose. So if you guys want to learn more, definitely feel free to check out any of these links that are in the slides. Okay. So with that, let's get started with the workshop component, and let's start coding. So first and foremost, our workshop plan is to be able to hook up our server with the database, and we want to create schemas and models for our comments and stories, and we want to be able to modify our API endpoints to use our Mongoose models instead of our dummy hard-coded data that's in the server. And we also have a cheat sheet that gives you guys code snippets for how to use Mongoose. So you guys can go to weblab.to/mongo-snippets for this. Okay, so that's in the chat. Okay, so step -1. So first and foremost, we're going to connect our app with Mongoose, right? So if everyone can run git fetch, git reset hard to reset all of the local changes, and check out the workshop 6 starter. And I will also do that. Make sure you are in the Capbook React repo. Oh. And git check out workshop 6 starter. And So now that you have checked out the Workshop 6 starter, we now want to connect our app to our Mongo database management system. So let's all go to server.js in our cat book. And what we want to do is we want to put the SRV that we get in our atlas into the Mongo connection URL. So you guys should have found or set up your MongoDB database by now. And so when you do that, you should have gotten your SRV and you should have created an account, a user, and a password, right? So this is the password that you created when you created the user. And so you can't find it anywhere. You just have to remember it. But for the username, you can go to, if you go to database access, you should find the username here. Oh, and if you don't have your SRV, or if it's hard, or if you're having trouble connecting with MongoDB, definitely put yourself to the help queue and the staff will help you, because it's really important to be able to actually connect up your application with your database. So I'll paste here. Okay. Okay, so I'll give people, I guess, 2 minutes to kind of set it up. And if you don't have your SRV ready, for now, you can just use this that we have provided, but do definitely try to set up your database ASAP, because it is very important to be able to connect to your database in WebLab. I do think it's like a requirement for the course to pass, so you definitely do want to actually be able to connect to it. So definitely do that ASAP. But I guess just to walk through connecting with your database, we have our databases here. And we have our cluster, and to connect to it, we just do connect your application, and this should be the SRV. So the user is here, and you want to insert your password here, and also your database name. Yeah. So more further instructions should be in the homework. So definitely do your homework if you haven't, or put yourself on the help queue so our staff can help. Yeah, database name is test, and you find the name of the database by here, sections. So this would be our database name right here, right? So, and then we would have different collections here. And so hopefully everyone got the SRV set up. If not, it's fine. Just use the SRV that was sent into the chat, but do try to set it up ASAP. It's very important. Okay, and so after you did that, run npm install and npm start. I think you can run either npm run start or npm start, I think. So npm install. npm start. So after the server gets started up, you should see a console log that says connected to MongoDB. So yeah, so you should see an output called connected to MongoDB when you run npm start. Okay. So moving on, the next step is to create our comment and story mongoose models. So recall from Akshash's lecture that for our capbook database, we want two collections. We want the stories collection and the comments collection. And each of these collections have documents or objects, the story objects and the comments objects. I believe they should have like creator name as well, but this is fine. And so if everyone can go to the models directory and open up stories.js, it should be a blank file for now. Okay. Right. So essentially, we want each story to have 3 fields. We want it to have a creator ID field, creator name field, and content field. And we want each of these fields to have the data type string. So does anyone have any ideas how we can enforce this structure on each of these stories? What should we do? Any thoughts? Exactly. Use a schema. So schemas are used exactly for this reason. We use it to enforce what fields that each of our objects should have and what types each of these fields should have. So let's first go to story.js, and make our schema. So the first thing we want to do is to import Mongoose. So we do const Mongoose equals to require Mongoose. So this just imports the Mongoose library into our code so we can use Mongoose. And the next thing we want to do is we want to define our story schema for the database. So we do that by doing const story schema. You can name it whatever, but it's probably more reasonable to name it something that's closer to what you want to store. And in this case, we're storing stories. And we define a new schema by using the new keyword. And then we do Mongoose. And we use the schema method, schema. And inside this schema method, we want to make a JavaScript object that defines the structure of the schema. So it defines the field and defines the data type for each of the fields. So in the case of a story schema, the password for your database should be from when you create your user, or your username in the database. So it's not, you can't find it anywhere. You have to just remember it. So if you don't remember it, you might want to create like a new user. So the password is just created. You create your password when you set up like your user. So when we create a DB user, we set the password, but that's the only time that like we would know the password. You have to remember it after that. So there's no actually any place where you can find your password. Yes. Okay. So now we want to define our schema. So the schema should have 2 fields, right? So we want, right, we want creator ID, but this ID is going to be generated automatically by Mongoose, so we don't need to worry about it. So all we need to worry about is the creator name and the content field. So we can do content creator name underscore name, and this field has a data type of string. And the second field we should have is content, and that should also have type string. Right. So just to recap, this step imports Mongoose so that we can use Mongoose in this file. And then this step makes a schema, a story schema for all of our story objects, right? But we can, of course, we can use the schema on other collections as well if they have like the same fields and the same data type. But this just defines what should be stored in a particular kind of object. And so for the story, it should have fields creator name and content, and both of these should have type string. And yeah, so if you put yourself onto the help queue, please also put like a Zoom link or a way that our staff can contact you. So yes, don't just put yourself on the help queue, because otherwise we have no way of finding you, so we cannot help you if we cannot find you. So definitely make a new Zoom, or maybe go to like a breakout room or something if that's available in this meeting right now. And then, so once we created our schema, the next thing we want to do is to define our model, right? So define the collection. So remember, a collection takes in a schema, but it also is kind of not the same as a schema, because multiple collections can follow the same schema but store different kinds of objects. So to define a new model, we can just export our model. So we don't really need to create another variable. We can just do module.export equals to, and here we would define our model or collection. And so to do that, we just do mongoose dot, and we use the model method. And model takes in a string, which is the name of the collection. So in our case, we can call it story. And it also takes in the schema that the collection, all of the objects in the collection should follow. So it's story schema. Right. So the module.export is just saying that if we import the story.js file from anywhere, we can just directly use this story model, right? So we can just export our model, and so we can use this model in other places once we import the story.js file. So that's what this is saying. Yeah. Okay. And so just to go over this step again, what we did was we first imported the Mongoose library. Then we defined our schema for the objects in the story collection. So we defined the fields that every object should have and the data type that each field should have. And then we defined our model, our stories model or stories collection, and this should create a stories collection in Atlas or in our database. And we export it so that we can use this model in other places in our code. Okay. Okay, so now that we've created our stories model, let's create our comments model. So this is what you should add. And so now it's your turn. So remember that we want our comment to store 3 fields, right? We want the creator name of the comment, the parent of the comment, and the content of this comment. And we want all of these fields to be strings. And also make sure to export the model. So I'll give everyone maybe 5 minutes to do this. We're a little bit short on time, so this might be a little bit rushed, this part, but I will keep my story code up because the definition of the comment model is basically very similar to this one. You just have to change several things.
Helen, should the word model be capitalized there?
Sorry?
Should the word model be capitalized there on the screen? It's yellow.
Oh, no, it should not be capitalized.
Okay, thanks.
Sorry. So yeah, so 3 steps. First step, import Mongoose. Second step, define your comment schema. And third step, define your comments model / collection. And then you want to export that. So you just want to add module.exports equal to whatever your model. I will also start coding up. Okay, I can also comment this and paste this. We can still see what's on. So this bottom is just the code for the story model. Okay, so our first step to define our comments model is to import Mongoose. So const Mongoose equals to require Mongoose. So step 1, import Mongoose. And we import things in the back end by doing this require whatever file. We don't do the thing we do in the front end, which is like import blah from path. So this is how we import things in the back end, in the server. And the second step is to define our comment. And so we do that by saying const comment schema. And we use the new keyword to define a new schema. And we do mongoose.schema. And inside these parentheses, we want to put an object that reflects the structure of all of the objects that follow the comment schema. So all of the field names and all of the types for each field, right? And so if we look back to our slides, we want 3 fields. We want the creator name, the parent, which is basically the ID of the story that this comment goes to, and we want the content of the. So 3 fields. So first, is the creator name. String. Parent, and it's also a string. And the content, which is also a string. And again, to re-emphasize, this parent field basically links to the ID of the parent story, or the parent story, or basically the story under which this comment was commented. And again, the ID field is auto-generated. Generated by Mongoose. So now that we've defined our comment schema, the next thing we want to do, step 3, is to create and export our comment model. Right? So this is just something that represents our comments collection, and we can use this model to basically interact with our comments collection on MongoDB. Right? So we can use the model to add objects to the database, delete it, edit things, etc. And to do that, to export it, we use module.exports, and we set this right-hand side to whatever we want to export. And so in that case, we want to export the comments model, and we have to define that. So to define our model, we do mongoose.model, and inside these parentheses, we take 2 parameters. The first parameter is the name of our collection, or name of collection here. And so in this case, we can call it say comment. And then the second field is the schema that all objects in this comments collection must follow. And so we've defined the schema above here. So we can use that schema. So again, just to go over the steps that we did to create our comment schema, it's the same steps that we made to make the story schema. So the first step was to import Mongoose so that we can use the library in our code. The second step was to define our schema for our comments, right? So we created a new Mongoose schema, and in that schema, we defined the fields and the data type for each field that we want in the schema. And the third step is to export our comment model. So module.export equals to, this just says exports whatever is on the right-hand side. And so this is what allows us to export the model. And so this right-hand side then just defines our model, right? So it creates a new Mongoose model that corresponds to the collection, the comments collection. So the name of the collection would be comments. It will probably add the S at the end. And this collection follows the comment schema. And what that means is that all of the JavaScript objects that we add to our collection, or all of the objects in our collection, must follow this schema. So they must have the creator name, a field that's called the creator name, parent, content, and all of these fields must be strings. And if it doesn't follow this format, so say it has another field, or it has a field name who's not creator name, parent, or content, or if the data types of the fields don't match, then if we try to add a object that doesn't follow the schema, Mongoose will not let us add it to the collection, which is good because it enforces exactly what we want. So it enforces the fact that we want objects of the same collection to have the same structure, or basically to have the same fields and the same data type for each field. Okay. Now, let us move on to the next step. So I guess first, for everyone to catch up, we can do git reset hard, and check out workshop 6-step 1, you probably need to save your SRV first or copy it before you do this step so that you can copy your SRV back into server.js. And as always, if you have any questions or need help, feel free to put yourself onto the help queue, drop questions into the chat or the questions doc. Okay, so I will also do git reset -- hard and git check out and git check out workshop 6 step 1. So if we look here, we should have everything that we did in the last step. And so our next step is to update our API endpoints to hook it up with our MongoDB database. So instead of retrieving data from the hard-coded data, we now want to retrieve data from our MongoDB database up in the cloud. So first, if everyone can open up api.js in the server directory. I'll go together. So notice how we now have we have 3 routes, 3 endpoints: get stories, post stories, get comment, post comment. So we'll do the get story and post stories together. This is what this step is. And then for the next step, you guys can implement get comment and post comment by yourself for extra practice. Okay. So okay. So the first thing we need to do is to update what we import, right? So in api.js right now, I believe only the story is imported, the story model. And we also want to be able to use the comments model. So we should also import that into our api.js so we can use that model. And by using that model, we mean we can use that model to kind of add things to our collection, the collection that corresponds to the model, or get things from the collection, etc. So we can think of the model as a way for us to interact with the collection that the model represents. So we can do const comment equal to require. So this just imports it. Import our model into the api.js field. /model/ comment. So this will be the first step. So whenever you create a new collection or a new model, you want to make sure that you import it. You always import it in your api.js file if you ever use it, right? So there's not really any point of creating models that you won't use. So you'll most likely need to import every single model that you create here. Okay. And so this is the line we want. Const comment equals to require, and inside the parentheses, we give it the path to the comments comment model, right? So this is the path from API to comment. So API right now is in the server directory, and to get to the comment directory, we have to go down into the models folder, which is in the same folder level as the api.js. So we use the dot. That just represents we're in the same folder level right now because both api.js and models are in the server folder, which is why they're considered on the same level. And then once we get to the models directory, under the models directory, we have our comments.js file. So this is what the path is. And so once we have our comment, once we have our comment imported, the next thing we want to do is to get our stories in the get/stories endpoint. So does anyone have any ideas how we would do this using our model and the methods or commands that we learned for the models? Try to find like a command or the code in the cheat sheet that corresponds to getting data from a model, right? And we want to return all of the stories. So that means we don't really want to have like a filter on anything. We just want everything in the collection. We don't need to like say like specify like kind of the conditions on like what kinds of stories we want. Yes, exactly. Find. Dot find, and we use the find method. And inside the find method, remember how find takes in a parameter, and that parameter is like an object that you can like specify the fields that the objects that are returned must match. But since we want all of the stories, we don't have any requirements, so this is just empty, so there's no requirements. So to do that, the first thing we want to do is to say we take the story model and we call find, and right. And then this method basically returns all of the story objects that are in the story collections, because here this is technically specifying like what kind of conditions or what kind of values that the return stories must have. But since we have no conditions, it will return everything. Right. And then, so then story.find returns a list of all of our stories, but we need a promise, because remember, these are all asynchronous functions. So essentially, we want to wait until we get all of our stories before we send our stories back to the user, right? So we don't want to send like, before like we even get a response from stories, because then that would be like an empty story. So then the user who calls this endpoint would like just get nothing, and that's not what we want. We want to wait until we get all of our stories from our database, and then send our stories back to the front end. So to do that, to do a promise, we do dot then. So this is just saying execute whatever's in this body of code after you finish finding all of my stories. And this dot then, remember, it takes in a function, and what it will do is it will execute this function after find finishes, right? And the input to this function is whatever is returned by find. And so in that case, it's just a list of our story objects. So we can just call that story. And then what we want to do is to say res. So in our response, we just send back story. And that's it. So again, just to recap what is going on in this body of code, we're saying that when the front end calls the stories API, the first thing we want to do is step one, we want to retrieve our stories / API data from our database, right? So this is what the story.find does. And the empty curly braces just means that we want all of the stories. So there's nothing that, like, we don't really want to filter out the stories that we get back. But maybe, like, say you want like a profile page for like a user, a specific user, and under that you want to display all of the stories that the specific user posts. That's when you want to, like, you specify something. So like if I want to like only find the posts that are posted by a specific user, I can like specify like creator name, name, blah, right? Where this is like the name of the user I want to find. But in this case, we want all of our stories, so there's nothing we want to filter out. Okay, so after we retrieve all of our stories, the next thing we want to do is to wait until we retrieve after all our stories, and then we send the stories that we received from our database back to the front end. So like in this case, it might like, remember how feed makes a GET request to stories, then basically it will return the stories back to feed. So this is what res.send does. So it returns it to whoever like calls the API. Okay, so step 2 basically is saying wait until I receive all of my stories and then send it back to the front end / caller, API caller. Right. So these are the 2 steps in this GET request. Okay, so moving on, because we are a little bit short on time, the next step is to implement the post. Okay, the post request, handling post requests from the stories endpoint. And again, this is what you want to code up in your stories endpoint, the GET endpoint. And so yes, now we want to implement post. And so this basically, here we want to create a new story based on the content parameter that's given in the request. But where do we get the content? So kind of a brief digression. We want to differentiate between rec.query and rec.body. And what this means is that GET requests and POST requests take data from different places. So GET requests take data from rec.query. So the parameters that are specified in the GET request will be in rec.query. So for example, if we want to like find all of the, if the front end sends our server, if we have an endpoint that says, hey, give me a username and I will give you all of the stories from this username. So the front end then must specify like the username of the person they want, right? So in this case, they would send over a parameter, and that would be like the username. And to retrieve that parameter, our backend would do rec.query.username. So it's not rec.body, but it's rec.query.username. But if we were doing a post request instead, the post request takes data from the rec.body object. So like if we wanted to post a story, then we would retrieve the content that was sent up from the front end by doing rec.body.content. Okay. And another note is when we implement the post request for a story, we just want to send up a dummy name for the name field because we haven't implemented usernames just yet. That will be coming next week. Oh, okay, that is unintended, but okay, so let's do that together. So for the post request, we would want to find another Mongoose method that would allow us to add stories to our model, right? So remember what we did was we need to create an instance of our story collection. So to do that, we do const new, let's use camel case new story equals to, and this use the new keyword plus the story to define a new instance of the story collection, right? And then inside this these parentheses, we want to put the fields for our object. So we want to instantiate our object. And remember, for each story, we have two fields. We have the creator name, and you should just put a dummy string. So in my case, I will put Helen, and the second field we have is content. And so this would then be whatever content is passed up to us from the front end, right? So when we made a post request, if you remember in workshop 3 to the server, or when we made a post request, we included the content, and that content was the thing we wanted to post. And so therefore that thing is what we want to add to our database, right? And so we get that we had a content parameter. So to get that, we do rex.body.content. There we go. Okay, so this just creates an object in our of our database that we want to add, but it hasn't actually added it yet. And to add it, we want to do we want to save it. We want to call the save function, right? So we do new story dot save, and then after we save it, we can just end it here, but like I guess like we can also, to kind of like make sure that we successfully saved it, we can wait until it finishes saving, and then we just return this new story, or the story object that we just created, back to the front end. So that maybe like the front end, on the front end side, you can like print out to make sure that the story, you've added the story. But theoretically, in practice, you don't really need this. Okay. So that's all for the get and the post requests for these stories. And so just to recap, what we did was for the stories, for the get part of the stories, the first thing we did was get all of our stories from our database, and then wait until we get all of our stories before we send these stories back to the front end. And for the post, the first thing we did, step 1, was we created a new instance of the story collection, right? And we instantiated it. I guess step 2, we instantiated our new instance with data given from the front end, right? So you want to use what the front end tells you to post to send it to the database. And then step 3 was to actually save the object in the collection via .save. And that's all you need to do. So get requests, like 2 steps, and 3 steps for the post request. So now it is your guys' turn for the comments. So you guys can run git reset -- hard and git checkout workshop 6 step 2 to kind of get on the same page. And remember to recopy your SRV into server.js. But yeah, so the first step is to implement get comment. And remember that the comment has to match a certain story, right? So we want to get comments for a specific story. So the only thing you guys need to do is to figure out what goes in here that you guys want to be sure that you only send or you only find stories or comments that belong to a specific story. So yes, this would be an example where you use the filtering function or the filtering features. And then in the post request, it's very, very similar to the post request for a story. The only thing we need to pay attention to is to add the parent, right? So I'll keep this up here, and we are slightly short on time. So I'll give you guys 5 minutes to do this, and then after 5 minutes, I'll start coding along as well, and then we'll kind of wrap up. So again, for the comments, getting the comments, you just want to find what you want to put here to only get the comments from the specific parent, right? From a specific story that the comments correspond to. So you just want to get all of the comments from a specific story. Get all of the comments from a specific story. So it's not like the find here where you can get all of the comments. You want to filter out and only get the comments that belong to a certain story. And then the post request part is very, very similar to the post request for the stories. The first step is to create an instance of the comments collection instead of the story collection. And then you want to instantiate your story or your comment object with fields from the front end. And remember to use rec.body instead of rec.query. So rec.body always for post requests. And also still put in like a dummy value for the creator name because that is, we haven't made users yet. So for now, just put like a random name or whatever you want. And then after you make your object, you want to actually save it and then maybe also like send back what was saved to the front end. But this is optional for a post request. It would be bad if you did not do that for a GET request though, because for a GET request, the purpose is to like actually send back the data from the database, or like send back data, right? You want to retrieve data for GET requests, but for a POST request, generally like you use it to like update the database as we see here. So like if you really want to return something, it's really for just like seeing if like it actually worked, or like if the object that you created was actually what you want, right? Because if you send it back, you can then like kind of console log it to see what the fields look like in like the console, actual console, instead of like the terminal console. Okay. And so that was 5 minutes. So I'm going to now code along for this step. So here inside the comments, what we want to do is we want to just find all of the comments that belong to a specific parent. So remember, in the comment schema, we have our parent field, and that's the field we want to filter by, because we just want all of the comments from the same parent, so all of the comments with the same parent string. So we get, because this is a GET request, remember, we get all of the parameters from rec.query. So we do rec.query.parent, so instead. Okay. Okay, so yes, so here, do not do rec.body.parent, right? So we use rec.query when we're doing GET requests, and rec.body when we're doing POST requests. Okay, and then that's all we need for this part. And for the POST request part, again, we're just going to follow the same 3 steps up here. So first, we're going to create a new instance of the comments collection. So we do const new comment equals to new comment. Going a little bit faster because we're slightly low on time. And in this comment, we want to instantiate our comment with the 3 fields here. And so again, we can hard code our creator name because we do not have a username yet. And then for the content, remember, when we send up the data for this POST request, we send up the content. So we get that by doing rec.body.content, because again, this is a POST request, so we use rec.body and not rec.query. So do not use rec.query. And then the last field we want is the parent. And this is also sent up to us by the front end, so we can access it by doing rec.body.parent. And again, do not use rec.query.parent. This is a POST request, so we use rec.body. Okay. So now that we've instantiated our comment, the next thing we want to do is to save our comment and basically officially add it into our database. So we use the .save function for that, so new comment .save. And then we can additionally add a promise to say, after we've saved, can you return the object that was saved? So comment, and once we have this object, we can send it back to the front end. So yeah, and this is it. So just to recap, for a GET request, generally, like when you handle GET requests in your API, what you want to do is to just find data from your database and return that data. But sometimes you might need to find specific data, so you don't want to find all of it. You want specific data that have specific fields and properties, right? So, and values. So in this case, like you only want comments from a specific story. So you would want to filter out your what you want to get from the database. And once you have to wait until the database returns all of the things that you request, and then you send back all of the things back to the front end via res.send. And then in the post request, essentially we did 3 steps again. We created an instance of our schema or of our collection of our comments model, and then we instantiated what we want to add to our object. So like we instantiate the values that this object will have. And then once we basically made this object, we then do .save to add it to our database. And optionally, you can wait for it to finish adding it to the database and returning it back to the front end, but this is completely optional for a post request. And also another important note to remember is to always use rec.body for post requests and rec.query for get requests. So these are what we want. Okay. And so we should be able to successfully post a story and a comment by this point. And to view the complete workshop, get reset -- hard and check out workshop 6 complete. And you should see your data in your database in the collections. And just to recap again, here we learned to understand how MongoDB database is structured, what schemas are and what models are. Remember, schemas are like the format which all the objects should follow, and models basically corresponds to like a collection. So every collection follows a schema, but different collections can have different the same schemas, but they might store different things, which is why we separate them into different collections. And so that's what these models represent. And we learned how to connect MongoDB instances to our Node.js apps, and we learned to interact with our MongoDB database via our APIs. So we learned how to kind of just use the Mongoose functions to get our data from the database or like add data to our database, and we use that API in the front end. And that's it. Okay. And for additional resources on Mongoose or MongoDB, check out these links, and I'll pass it on to Mufaro for int CSS.